students. Module 8. We are now on the brink of a green energy revolution, when more and more renewable energy production plants are created in order to fight the climate change, to reduce the greenhouse gas emissions pollution and to ensure a sustainable future for our planet. This offers huge opportunities for people and companies, and it is very important for you to understand what green energy is and to gain knowledge, skills and abilities related to its production as well as with related operations, such as the maintenance of energy production facilities. The maintenance of solar panels is an important activity as it ensures the maximization of their solar energy production and ensure they last a long time, with great economic and environmental benefits. With this module, you will learn about maintenance, in general, and about the solar panels maintenance in particular. The maintenance operations typical for solar panels are discussed together with their importance and benefits. In addition, you will learn about the safety practices related to solar panels maintenance operations, including specific risks and safety measures. Basic concepts of maintenance. Definition of maintenance. Maintenance refers to a combination of technical, administrative and management measures which aim to ensure the preservation of an observed unit, such as a solar plant, or to restore its functionality. It includes 4 basic measures: inspection, service, repair and improvement. Inspection, measures for assessing the actual condition of the observed unit, including identifying the cause of wear and deriving the necessary steps to ensure its future use. These include checking, measurement, observation, assessment and deriving consequences. Service, measures to delay the reduction of the existing wear reserve. These include visual inspection, adjustment, supplement, lubrication, preservation, cleaning, and functional testing. Repair, measures carried out to restore the functioning of a faulty unit. These include unit exchange, restoration of functions and breakdown resolution. It also aims to eliminate damage or signs of wear, in order to avoid hazards or functional failures. Improvement, measures to increase unit's functional reliability, maintainability, and/or safety without changing its required function. These include elimination of weak points and improvement in machinery and plant design. Figure 1. The 4 basic measures of maintenance. Types of maintenance. Maintenance can be classified in 2 main categories: scheduled maintenance and unscheduled maintenance. Figure 2. Maintenance categories. 1.2.1 Scheduled maintenance. Scheduled maintenance is planned in advance and done at regular intervals. It is based on routine maintenance, repair and prevents faults from occurring. Scheduled maintenance of solar panels should be performed during non-peak hours and preferably during the night hours. Scheduled maintenance includes 2 general approaches: preventive maintenance, condition-based maintenance. 1.2.1.1 Preventive maintenance. Preventive maintenance is performed before machine or system failures occur and involves routine inspection, servicing and cleaning of solar panels at a scheduled interval of time. The goal is to minimize downtime and unnecessary production losses, to improve panels' performance, to increase the availability and to reduce the probability of the equipment failures. The main activities under preventive maintenance include checking of mounting structure integrity, module cleaning, hotspots detection, junction box servicing, inverter servicing, checking the cabling connections, checking the various supporting and auxiliary components of the solar power plant system, inverter servicing, checking the earthing protection, vegetation control. 1.2.1.2 Condition-based maintenance. Condition-based maintenance involves monitoring in real time of equipment condition and plant operations and addresses the potential problems at an early stage to prevent interruptions. This method uses periodic measurements to detect signs of equipment deterioration in order to extend its service life by avoiding imminent problems. It improves the performance and efficiency of solar systems by anticipating failures and avoiding them at an early stage. Condition-based maintenance requires special diagnostic equipment and a good equipment performance monitoring system which can extend and improve the life of the solar plant. 1.2.2 Unscheduled maintenance. Unscheduled maintenance addresses the failures after they have occurred. The important parameters are diagnosis, repair time, and speed of response. It includes only one general approach to maintenance management, the corrective maintenance. 1.2.2.1 Corrective maintenance. Corrective maintenance is performed when damage has occurred and involves the repair of faulty equipment. Corrective maintenance includes tightening loose connections, replacing damaged modules, replacing blown fuses, repairing blown fuses, correcting inverter faults, fixing equipment damaged by intruders, substituting blown connectors, correcting SCADA faults, remedying faults of mounting structure. Benefits and drawbacks of maintenance. In general, good maintenance practices are beneficial for businesses. However, several factors need to be considered in order to understand if maintenance is helping or hurting a certain operation. The main advantages of maintenance are as follows. Increases the lifetime of equipment. Optimizes the equipment performance. Helps avoiding the unscheduled downtimes. Minimize the costs related to equipment breakdown. There are also some disadvantages related to maintenance. Additional expenses. Lost productivity, when the unit or parts of it need to be shut down during the maintenance. Possible safety risks. Solar panels maintenance. The need for maintaining solar panels. The solar panels are designed and built to handle tough weather, snow, and dirt, so after installation, unless something breaks, they should function properly without maintenance. However, a proper maintenance of solar panels guarantees the maximization of their solar energy production and ensure they last a long time. The regular maintenance of a solar panel system should check and ensure solar panels are clean, secured in place and free of defects. There are no deteriorated or corroded parts. The switches do not have any defects and work properly. Wiring is not damaged or deteriorated. All electrical components are operating as intended. Fittings and cables are securely attached. Reviewing the inverter display panel for recorded faults. Checking that access to the isolator switches has not been impeded. Making sure the emergency procedures for shutdown and isolation are clearly displayed. Service of solar panels. Inspection of solar panel servicing includes various activities aiming to ensure their optimal functioning for a long time. These mainly comprise visual inspection, cleaning, functional testing, and some routine checkups such as corrosion inspection, vegetation management, shade control, wiring verification, etc. The general visual inspection activities that must be conducted during visual inspection of a solar plant are as following. Equipment grounding verification. Identification of hazards. Inspection of weatherproofing systems. Inspection for wiring damage. Identification of damage due to corrosion. Identification of mismatched equipment. Documentation of findings. The critical activities that must be conducted during visual inspection of solar panels are as following. Inspection of solar panels mounting. Inspection of solar panels integrity, checking for moisture condensation within the solar panels, corrosion of contacts, delamination of cells, cracks on the cells. Identification of cell discoloration. Identification of damage to panel glazing. Verification of panels shading. Verification of panels cleanness. Inspection of unsupported wiring. Identification of ice damage. Identification of water ponding. Solar panels cleaning. Since the energy produced by a solar panel depends on the sunlight it is able to collect, anything that blocks its exposure to sunlight affects its performance. An accumulation of dust, debris, and other things will reduce the amount of light that reaches the solar cells, negatively affect the solar panel's performance, so their cleaning is required in order to optimize the solar energy production. Depending on the size, installation height, available utilities and equipment, etc., the cleaning of solar panels can be done using pressured water, soap, and various tools or special machines. Recommendations regarding solar panel cleaning. Abrasive sponge or soap should be never used for solar panel cleaning, to avoid scratching the glass. The best way to clean solar panels by using a soft materials and biodegradable soap. The best is to clean solar panels when they are moist or wet, so any dirt or residue that is stuck on them can be wiped off easily. The best is to clean solar panels in the morning or evening. During the middle part of the day the panels can get very hot, making cleaning dangerous for both worker and the panels. It is important not to use harsh materials when cleaning solar panels, as they could cause damage. If water is used to clear the snow away, it must be lukewarm. Hot water should be never used for clearing snow off the panels. Solar panels are made of tempered glass, and the extreme temperature difference between hot water and cold panels can crack them. Never use a pressure washer on solar panels. Although the glass is quite durable, they are not designed to be hit with high-pressure water jets. All necessary work safety measures must be taken. Shade control. Panel cleaning. Solar systems generate electricity based on the amount of sunlight they receive. Therefore, when a shadow is cast on panels, the power output decreases substantially. Shading can come from a variety of sources. Nearby obstructions, such as trees, buildings, chimneys, antennas, or poles. Self-shading from the adjacent solar panel rows. Horizon shading from the terrain surrounding the installation site. Other factors such as panel orientation or soiling. The main activities related to shade control are dealing with vegetation trimming and, when possible, the removal of other obstructions. Maintenance plans. Maintenance plans are important to ensure necessary tasks are performed. They should include all the necessary maintenance tasks and their respective schedules. Monitoring the solar panels. A solar panel monitoring system allows for tracking how much energy the panels produce on any given day, and how much they produce over time. Thus, it's possible to see exactly how various external factors affect the panel's performance and how well they are maintaining their efficiency across their lifetime. Monitoring the performance of a solar system through daily, monthly, and annual checks is the best way to detect a problem in the system. Safe practices for solar panels maintenance. The risks related to solar panels maintenance. The maintenance of solar panels and systems can be high-risk work if the hazards are not recognized, assessed, and controlled or eliminated. Due to the rapid growth of the solar energy industry, more workers are being exposed to those hazards all the time. They must be properly familiar with its characteristics and the applicable safety measures, which must be followed while maintaining the solar panels. One reason why solar panel systems are dangerous to work with or near is that they are very often installed on rooftops or on the sides of buildings. Consequently, some maintenance activities may imply working at heights, so falls are a major concern. In addition, the solar panels generate electricity all the time except in complete darkness, so anyone working in proximity to a solar panel must respect, understand, and take precautions when completing their tasks. Some common hazards faced by maintenance workers are electrocution or other electric hazards, falls from heights, slips, trips, and falls, weather-related hazards, repetitive stress injuries, cuts or sprains. Even if it is possible that a solar panel system is maintained by a single worker, this is a dangerous practice because in the event of an incident, there could be no one there to apply the emergency response plans. Safe work practices. The risk of accidents related to solar panels maintenance can be reduced through proper training and education of workers, appropriate personal protective equipment, and a job safety analysis. A job safety analysis should take into consideration the tasks that can result in injuries for workers who conduct solar panel maintenance work, such as using power tools, working with ladders, working in extreme weather, climbing or working near roof edges and skylights, working alone, and skylights, hoisting and rigging, manual handling of heavy material, proximity of electrical utilities with chance of electrical contact. Because of the risks that businesses and workers face, it is necessary for employers to have safety training and protection for their employees. Employers have a duty to take every precaution reasonable to protect their workers and should establish safe procedures for working around photovoltaic systems. This procedure must include an emergency response plan. In addition, companies should update their health and safety policy and program to include procedures for operating around solar installation.